Good evening, good friends. Welcome to today's session. I don't know if maybe that is visible on top there. Let me see. Yes, I think it's visible a bit. We will be dealing with analytical geometry. What I want to do today is that I want us to dissect analytical geometry from grade 10, grade 11 up to grade 12. I'm going to show all of analytical geometry, meaning from the basics, where it comes from, and then the manipulations and everything. So I hope you'll be able to enjoy and see everything that needs to be seen. It's a bit cold today, so I'm having coffee. Just fetch my stuff. Yes. So in grade 10, some of the things that you were told is that in analytical geometry, you are going to deal with stuff like the first one will be the distance formula, or rather the distance between two lines, maybe from point A to B, how to calculate the distance. And then the second part will be the midpoint. Most of these things are self-explanatory. Midpoint meaning the middle point of a line, and then 3 will be something like, let's say, I can include gradient of the line, which is gradient, which is a slope, rise over run, and what else also? Distance, midpoint, gradient. Maybe I forgot something. I'll think about it. I'll remember it as we go forward. Let's start with distance. 1. Distance. So when I speak about distance, I remember I was teaching my learners about vectors and scalars, grade 10, introducing them to vectors and scalars, and I was showing them why we are saying distance is a scalar quantity, not a vector quantity. But now we are going to talk about distance mathematically. So when they are saying distance formula, I'm going to create maybe a line here. Maybe this is A and this is B. And the coordinates of this point, maybe it's going to be 2 is to 3. That point is going to be 3 is to 7. Yeah. So when they ask you to find the distance of a line, meaning how the length basically of a line, you'll be saying distance of line, in that case is AB, is going to be equal to the square root of, I normally like to do it this way, irrespective of whatever line or other coordinates you have. You can say xb minus xa, all of this is squared, plus yb minus ya, all of that is squared. But if maybe you have started this way, instead of starting with b here, you started with xa minus xb all squared. You need to also, on this side of the y's, start with yb, sorry, not b, start with ya minusing yb, and then you square it. Whatever that you started with here, you should also start with it also here, such that they can correlate and you can be able to see and use coordinates in a correct fashion. So now let's solve this thing. Let's find the distance of line AB. So using the first or the second one. So I'm going to try and squeeze it here with the first and the second. So here's going to be the first formula, distance of AB. I'm going to call it first and then the second. This is going to be first and this is going to be the second. Why am I showing you both of them? I want to show you that the answers are still going to be correct either way. Let me just fetch my calculator. Yes. So with the first one, we will have the square root of xb is going to be 3 minus xa, 2. All of this is squared, plus yb is 7 minus ya 3, all of that is squared, and then we'll end up having 3 minus 2 is 1 squared plus 7 minus 3 is 4 all squared, and this whole thing is like 1 plus 16. It's going to be the square root of 70. Now let's check in this, let's write it units. Let's check this side if we're going to get the same answer. So we said XA. So we start with XA is going to be 2. And then 2 minus 3 squared plus 3 minus 7 squared, which is going to be equal to negative 1 squared plus negative 4 all squared, which is going to give us square root, negative 1 squared is going to be 1 plus negative 4 squared is going to be 16, which is basically going to be the square root of 17. As you can see, both of these answers are correct using the same different methods. What I wanted to emphasize is that what you started with here, you also have to start it with here. Similarly here, there. That's basically the whole idea. Because the moment you change them, the answers won't be the same and they won't correlate, and then you'll end up getting the wrong answers based on the fact of you not swapping or rather substituting correct coordinates. So, and then I hope with this particular way or rather method or rather way of doing it, this is clear. Let's proceed to midpoint. I need to get myself a bigger board. A bigger board. Let's say big or larger board. I don't know. I use black. Okay. Now we check midpoint. So as you can see, line AB, there has to be the middle point between those 2 points, meaning I'll just presume that the midpoint is here. So we need to find the coordinates of that point. Let's call it X. We are looking, when you find the midpoint of a point of a line, you are basically looking for the coordinates of the point of the middle part of this line. So maybe, I don't know if maybe this glasses are making a reflection. I just remove them. So you are finding the coordinates of that line. So when you find the midpoint of line, let's say AB, you will be saying XA plus XB all over 2 is to YA plus YB all over 2. And then we have here XA is going to give us 2 plus XB 3 all over 2. YA 3, YB 7 all over 2. Here we have 5 all over 2. Here we have 10 over 2. 5 over 2, let me leave it at that and not write it as a decimal. Here 10 divided by 2 is going to give us 5. So the midpoint of this line AB is basically 2.5 is to 5, or rather 5 over 2 is to 5. So I hope that makes sense. You don't say XA plus YB. No, the left part of the coordinates is reserved for the x-intercept, and then the y part of the coordinates is reserved for the y-intercept. Hence, we are saying xa, xb, and then ya, yb, because we are looking for the coordinates of point x. Now, a question might arise and say to you, you are given these coordinates as these, as 5 over 2 is to 5, and then you are asked maybe to find the coordinates of B, which is basically, let's call them X and Y. And then how are you going to do that? In the case of this nature, I'm just going to squeeze it underneath here. In the case of this nature, you have the coordinates of the midpoint of AB. So in that case, you will be saying You'll write the formula as I wrote it here. Midpoint of AB is going to be XA plus XB all over 2, YA plus YB all over 2. Therefore, here you do have these coordinates. So I'm going to write 5 over 2 is to 5 equal to, now we do have XA, right, which is our 2. I'm going to say 2 plus XB. I'm going to write it as XB all over 2 is to, we do have YA, which is 3 plus YB. I'm going to write it as YB all over 2. Now let's check. Let's pay attention to details. This is X, this is Y, and this is X, and that is Y. What we are supposed to do, we are supposed to equate X's with the X and then Y's with the Y. What does it mean? I'm going to say 5 over 2 is equal to 2 plus XB all over 2. Then I do that, and then I have 5, which is going to be 3 plus YB all over 2. Then from here, I'm just solving algebraically to find XB and then YB. In this case, I'm going to multiply both sides by what? 2. What is going to happen? I'm going to have 2 multiplied by 5 over 2 equal to 2 plus YB all over 2 multiplied by 2. The same is true here. I'm going to have 5 multiplied by 2 is going to be equal to 3 plus YB all over 2 multiplied by 2. So I'm doing it at the same time simultaneously, but I just hope it makes sense. The 2 is going to cancel 2. I'll be left with 5, which is going to be 2 here, cancel the 2. 2 plus Y, is it Y? No, it's X, plus XB. Here I'm going to have 10, which is equals to 3 plus YB. Then I'm going to transpose. 5 minus 3 is going to, minus 2 is going to give me 3, which is XB. And then here 10 minus 3 is going to give me 7, which is equals to YB. So as we can remember, YB, as you can check it here, it was 7. XB here, as you can check it here, it was 3. So it gave us the correct coordinates, which is 3 is to 7, as the ones that we already had there. So you can have this two types of questions, whereby you will be asked to find, the coordinates of the midpoint of line AB, and also can be used, you can be given the coordinates, or rather, yes, the coordinates of line AB, the midpoint of line AB, and asked to find a particular point in that particular line. Can be A, can be B, can be X, whichever way they would want you to find, whichever thing they would want you to find. So this is how you do it, and I hope it makes sense. Let's proceed. And then we are going to the gradient. I'm having flu, but I'm a bit better today. In my previous video, it was a bit tough, but now I think I'm only left with mucus and phlegm, but it's not much of a problem. It's not much of a problem. When you find gradient of a line, I'm going to draw another line here. I'll draw another line. A, B, A, B, A, X, B. Let me call this line -2 is to 6. Here I'm gonna have -1 and 5, maybe. I don't know. There I can have 1 and -6. I hope it makes. I hope it works out. I don't know. As you can see, just guessing. So now let's find the gradient of line AB. So gradient of line AB, I'm gonna say MAB. It's going to be. This doesn't look clear. Looks like it's not visible. So let me continue with my red for danger. MAB. I'm gonna have YB minus YA all over XB minus XA. The same is true again. If you remember what I've done here on the distance part, I said if you can swap the two and rather start with ya minus yb to be also what you've done on the top in the numerator, you must also do in the denominator to have xa minus xb. It is still going to give you the same slope. So there's something that I want to tell you about the gradient. When your graph, or rather, yeah, the line is slanted like this, you see, like it's slanted like that. I don't know how to pronounce that, but if it is slanted like this, the gradient has to be positive. But if it is slanted like this, the gradient ought to be negative. So let's test this particular thing here. We had 3 and 7 here, if I remember very well. Yes. So now let's test. If the answers are not going to give us the correct answers, remember that these two were taken just from the top of my head. I just pray they come out all right. I'm going to remove this formula. It messed it up. So now let's check. We'll be saying what is our b? Yb is going to be 7 minus ya is going to be 3. Xb is going to be 3 minus 2, which is going to be 4 all over 1. Our gradient is going to give us 4. So gradient of line AB, beautiful, positive, to show the thing that I was talking about. If the gradient, if the line is slanted like that, therefore the gradient ought to be positive, which is a 4. Now let's check this one, if it gives us a negative. This line, let me not call it AB. Let me just say it's AB, let's call it C and D. So I'm going to say gradient of line CD is going to give us yd minus yc all over xd minus xc. What is the coordinate of line D? I mean point D is minus 6 minus point okay, let me call it 2. Let me call it 4. Yes. That's fine. Let's do it. Minus 6 minus 4 all over 1 minus into minus 2 into minus 2. So we'll be having on top there is going to be negative 10. In the denominator, we're going to have negative is going to give us positive 3. So the gradient is going to be negative 10 all over 3. As it is visible now, the gradient of the line that is slanted like this is negative, as the numbers have proven to us that when you slant the gradient, the line this way, the gradient becomes negative. When you slant the line this way, the gradient becomes positive. So we have managed to calculate and find the gradient of those two lines. Something else that I want us to look at, pay attention to, which is called collinear points, gradient of collinear points. If you're asked to say, they say to you, show that xy, axb and cxd are collinear. What does that mean? It means that their gradients are the same, or their gradients are the same. That's what it means. So collinear points have same gradients. They have equal gradients. Let me see if this will be visible. Maybe. Collinear points have the same gradient, or rather equal gradients. So let's start with line AB first. So for line AB, we found out that the gradient of AB is 4. So let's find the gradient of AX. If the gradient of AX is 4, and then we find the gradient of XB is 4, therefore AXB are collinear. So I'm going to say gradient of AX, which is going to be YX minus YA all over XX minus XA. Yes. Let's try purple. What is YX? Is 5. So I'm going to have 5 minus YA 2. Going to have 2. Cool. XX is going to be 5 all over 2 minus XA is going to give me a 2. So now I'm going to do this. Here in the numerator, 5 minus 2 is going to give me a 3. Now I'm coming here in the denominator. I want to show you something beautiful now. Our denominator in this fraction is 2. So I'm going to have 5 all over 2 minus, here I have a 2. In order for me to have a denominator of 2, I can have 4 divided by this 2 to have the same denominators, which is going to be 4 all over 2. I know 4 over 2 is going to give me that 2. So now I have common denominator, which is 2, and then 5 minus 1. 5 minus 1, 5 minus 4 is going to give me a 1. So the answer for the denominator is going to be 1 all over 2. So in this case, I'm going to have 1 all over 2. All right. And then what else am I left with here? I am left with 3 divided by 1 over 2. So this is the same as 3 over 1, which is going to be 3 over 1 multiplied by 2 over 1. And then in this case, it's going to give me a 6. So the gradient of line AX is a 6. Let's proceed to find the gradient of line XB. So MAX is going to give us 6. We are coming. We'll see. Let's use a calculator just to confirm. 5 minus 2 all over 5 over 2 minus 2. Yes, it's a 6. And then let me check something else. Minus 3 over minus 2. Yes, all is well. So now we find the gradient of line XB. So I'm going to have YB minus YX all over XB minus XX. YB is 7 minus 5, and then divided by 3 minus 5 all over 2. So now I'm going to erase this part such that I can calculate here. I have a calculator, but I enjoy doing this part. And okay, so 7 minus 5 is going to give me a 2. All right, and then here 6 divided by 2 is going to give me a 3. So I have 6 over 3 minus 5 over 2. And then, 6 divided by 3. That's the one that's going to give me 6 divided by 2 is going to give me 8. 2 4 6 is 6 divided by 2. So now I have a 2, 6 minus 5. Therefore, this is going to be 1 over 2. I have here 1 over 2. Then I'm going to have 2 divided by 1 over 2, which is the same as 2 multiplied by 2 over 1, which gives me a 4. Now, there's something that I am realizing here. Gradient of line AB is 4. And then the gradient of line this is 4. But the gradient of this line is 6. What could be the problem? What could be the problem? Let me check if maybe what I've done was not a problem. 5, 8, 5 over 2 minus 2. I am the one who made a mistake. I am the one who made a mistake. The answers are the same. All of them are the same. So we found that the gradient of line XB is 4. So now let's fix the gradient of line AX because it's also 4 after checking it on the calculator. Maybe black would do AX. So I'm going to have YX minus YA all over XX minus XA. So YX is 5. 5 minus 3 all over 5 over 2 minus yeah, that other one was was flat. So now I have this one now. So yes, these are the mistakes that we normally make. Everybody makes these mistakes, and it's beautiful that I made it, such that you can see what you need to do. You don't panic, you double check, and then you go back to your scenario and you do it again. Beautiful. I'm happy that we dealt with that. So now those were the basics. Those are the first steps. Now let's get into some other beautiful parts. Beautiful parts of analytical geometry. I need to check a question in a particular book that we can solve that involves such things. So before those questions, I'm going to show you something else, such that when we fetch a question, we know that we have touched all of the basics of this particular topic. Uh, Normally use this book. Whenever I feel like practicing or doing anything, I use this book. And also, of course, Kevin Smith, I use this also to practice. I'm going to take problems from here and also from there. Let's check analytical geometry. Now that I took my spectacles off, my sight is a bit funny. Page 76. Now here's a beautiful question that you can deal with and then solve to find out what can we do with whatever that we've learned. So I know it's analytical geometry, but there are some few things that you need to remember of. I'll call it Euclidean geometry in this case. So we have SPQR, and then the questions that we are asked here are not what we've dealt with, are not what have shown you, but we are supposed to use those things that I've shown you in order for to help us to solve these questions. You know, the question says show that triangle PRS is isosceles. So where's PRS? This is sorry, I'm going for PRS is there. So what are the properties of an isosceles triangle? You need to remember that opposite sides are equal, and then adjacent angles are also equal. In this case, we need to show, based on whatever that I've taught you, you need to show that the opposite sides are equal. How do you use that? How do you show that? By showing that the distance from P and R, I mean PS, you can either check it this way. You can say PS or PR. If these two lines are equal, therefore this triangle is isosceles. Or PS and RS. If these two lines are equal, therefore the triangle is isosceles. How do you check if the lines are equal? By checking their distances. That's where you apply that particular thing that I've started with, which is the distance formula. So let's start first by checking PS and RS. So that simply means you will not just come and say PS and RS are equal without you proving it. Mathematics is about proofs. So without any proof, therefore your mathematics is it's quirky and it's wobbly, because we don't take things, we don't just gamble and think that things are like that because they look correct. They should not look correct or sound correct. They must be correct. So now let's check the distance. I'm gonna say solution. So for the first one, I'm going to say distance of PS, not the chocolate. PS is going to be equal to xp minus xs, all of this is squared, plus yp minus ys, all of this is squared. Now I'm coming back here, not to the drawing board. Now xp is 2. I'm going to have 2 minus xs is minus 5. Open the bracket, I write minus 5, and then I square the whole thing plus. And then yp is 6. I'm going to have a 6 minus ys is 7. I'm going to have 7 and then square it. And then eventually I'm going to end up having this thing. 2 negative multiplied by negative is positive. 2 plus 5 is 7. So I'm going to have a 7 squared. Here 6 minus, plus 6 minus 7 is negative 1. So I'm squaring it. So I'll end up having what? 49 plus 1, which is the square root of 50. Someone would want to say is like 2 multiplied by 25, which is basically 5 root 2. It's fine. It's fine. You can stop, leave it here, or take it further there, showing us how good you are with SATs. So now let's check the distance RS. Distance RS is going to be, x r minus xs squared plus yr minus ys squared. xr is negative 2 when I have negative 2 minus xs is negative 5 all squared plus yr is 3 minus, and then ys is 7 all squared, and then we'll end up having this, which is going to be negative 2. This is going to be a 5, positive 5 squared plus a negative 4, and then here we'll end up having a positive 3. Let me just write it as a positive 3, and then this is squared. This is going to be what? This is going to give me a 9. I'm going to have a 9 plus 16, which is going to give me the square root of 25, which is going to be 5 units. Should have written units here. So now it is clear that distance PS is not the same as distance RS, right? So if distance PS is not the same as distance RS, either this and that. So you come again and you check. We did PS and RS. So now I know that distance PS is square root of 50. Let me leave it at that. Or basically 2 root 5, or rather 5 root 2, sorry. 5 root 2. And then distance RS is going to give me 5 units. So now I have this distance and that distance. Let me find distance RP. So by finding distance RP, I'll end up having XR minus XP all squared plus YR minus YP all squared. This will be, what is my XR? Is negative 2. Negative 2 minus XP is 2 squared. All of that is squared plus YR is 3 minus, and then YP is 6, and then this is squared, and then I'm going to have what? Negative 2 multiplied by positive 2 is going to give me negative 2, and then two negative 2s are going to give me negative 4, and then I'm squaring it, plus 3 minus 6 is going to give me negative 3, and then I'm squaring it. I'll end up having 16 plus 9, which is going to give me the square root of 25, which basically gives me a 5 units. So I now see that distance RP is going to give me 5 units. So what does that mean? It means that if distance RS and distance RP are equal, distance RS and distance RP are equal. Therefore, triangle PRS is an isosceles triangle because opposite sides are equal. How did I check it? I checked it using the distance formula. This is what we've done a few moments ago, but now look at how we apply it. We do not just draw a line and just say find the distance of something. We are saying to you, giving you a triangle and ask you to utilize this particular thing that I said we should do, and then after doing that, we basically get what we need. So this is basically the whole idea of mathematics. I give you something in order to open your brain to be able to can solve other cumbersome problems that will make your mind to open up, to sharpen up your mind, and don't just think outside the box, but like think, have some source in your thinking. So I think this is great. This is beautiful. We can proceed to this one, the right angle triangle. There's something that I did not show you with the right angle triangle, but I'm going to show it to you now. How to show that something is a right angle triangle. I know a number of people are busy watching the FIFA World Cup final, but look at where I am now, doing the FIFA World Cup final of your academics. Beautiful. Now, let me see if this is visible. I don't think it is. No, it is not. Let's proceed with this color. I don't know what color is this. Now, when asked, I just want to write it as a note. When asked to prove that a triangle is a right angled triangle, you must find gradients of two lines, then multiply them and they must give you a negative 1 if it is a right angled triangle. This is the first method. You can just find gradients of two lines, multiply them, and then they must give you a negative 1 if it is a right angle triangle. That is the first method. The second method is for you to do what? Find their distances, and then after finding their distances, you square them like you do with the Pythagoras theorem, meaning, for example, we found that the distance of here is 5, here is 5, here is 5 root 2. So in this case, if you want to find this is a this is a right angle triangle, what we can do is this. I can say 5 squared plus 5 squared is going to give me this distance. Let's check it first before we do that one. I'm going to say PR squared, or rather RP squared plus RS squared is going to give me SP squared. We had already found the distance there is 5 squared plus, here we know that is 5 squared. Here we found that is square root of 50. Alright, and then here we'll be having 25 plus 25. Let's leave it as SP squared, but we knew that it is square root of 50. So we'll be saying SP squared. And then distance here is basically total is 50 SP squared. And then we can say this square root, and then SP is going to give us square root of 50. So that simply means without going any further, we can utilize that one or this one using theorem of Pythagoras, but the first one that I've shown you here. So that we just saw that using theorem of Pythagoras, it gives us exactly that this PRS is an isosceles triangle and it's also a right angled triangle. So let me use this method that I said that I've written first. Two ways, same answer. Now, let me find the gradient of line PR. MPR. It's going to be YR minus YP all over XR minus XP. What is my YR? Is 3 minus YP is 6. XR is negative 2. XP is 2. So on top there, I'm going to get a negative 3. In the denominator, I'm going to get negative 4, which is going to give me positive 3 all over 4. And then I'm going to find the gradient of line RS. YS minus YR all over XS minus XR. Now, what is it that we're going to do? I'm coming here. What is my YS? Is negative 5 minus YR negative 2. in the denominator. I have x, no, I made a mistake here. Ys is 7 minus yr is 3. Xs is negative 5. Xr, negative 2. On top there, I'm going to get a 4. In the denominator, I'm going to get negative, it's going to be positive 5. Negative 5 plus 2 is going to give me negative 3, which basically is going to be 4 all over 3. So now, like I said, this is the statement. The lengthy thing that I wrote is like this. Gradient of 1 multiplied by the gradient of 2, they need to give you negative 1. Let's prove this reality. I have the gradient of PR, or rather RP, multiplied by the gradient of RS. They need to give me negative 1. What is the gradient there? On top is 3 all over 4. Multiply the gradient in the denominator is negative 4, not denominator, the 1 of RS is equal to negative 4 over 3. They need to give me negative 1. So 3 cancels 3, 4 cancels 4. I have negative 1 equal to negative 1. So it is proven using two methods. The one of theorem of Pythagoras, the second one of the gradients. So you need to be versatile as a mathematician. You need to know your stuff. You need to know all the basics and be able to can prove. If you used one method, you can utilize another method to confirm that your answer was correct. We answered the second question. Let's come to the last question. Prove that triangle PRQ is a scalene triangle. Scalene triangle means that none of these sides are going to be the same. So meaning we need to find the distances of all of these sides. They are not supposed to be equal. If we find two equal sides, that simply means that's not a scalene, it's an isosceles. If we find all of the sides are equal, that simply means that's not a scalene or isosceles. It means it's an equilateral triangle. So now let's find distance of TQ. It's going to be XP minus XQ all squared plus YP minus YQ all squared. XP is going to be a 2 minus XQ is going to be a 5 all squared plus YP is going to be a 6 minus, and then seems like I made, okay, 0. And then this is going to be negative 3 squared plus 6 squared. It's going to be a 9 plus 36, which is going to give you the square root of 45 units. And then distance of PR. This one we knew that distance of PR, we already found it there on top that it is 5 units. So we don't need to overwork ourselves. So let's find the distance of RQ. Distance RQ is going to be XR minus XQ all squared plus YR minus YQ all squared. XR is negative 2 minus XQ is 5 all squared plus YR is 3, and then YQ is 0 squared. And then here we will be having negative 2, negative 5 is going to be negative 7 all squared plus 3 minus 0 is 3 all squared. And this is going to give us what? 49 plus 9, which is 58, square root of 58 units. So it is clear that square root of 45, it is not equal to 5. It is not equal to the square root of 58. Therefore, triangle PRQ is a scalene triangle. What did we use? We used the distance formula. So I started showing you the distance, the midpoint, the gradient, and then I'm showing you how to use these things. So you see, they can give you such things and then ask you to find them in a particular method. So you need to be able to utilize these things, and then this is beautiful, guys. This is beautiful, and I hope it makes sense. This is just the first part of the video. I'm going to do more lengthy videos, and then I hope it makes sense, and I hope you understood every aspect of the things that I've spoken about. Even my coffee now is cold, but then I'm just happy that I got a chance to deal with this particular topic. There's the first part, moving forward to making sure that you pass and you understand. Hope to see you soon. Don't forget to subscribe to my YouTube video. It's Lemaula. Let me just again this. You can just check Lemaula. Do this. Lemaula. Like this. Lemaula. It's fine. You can use it. Yeah, Lemaula do me is YouTube. It's not a P, it's a D. Yeah, YouTube channel. Go subscribe, like, share, comment, do whatever that you want to do. But this is where you can find me. I'm going to pause this and then hope to see you soon. Thank you very much. Enjoy. Bye-bye.